Now we will discuss some types of sets. In that, first of all, we are going to discuss about empty set or null set. So now see here, sometimes a set with a common property could not have any element. Okay, with the common property, might not be any element in the set. Okay, if that happened, then a set with no elements in it is called a null set. Okay, if there is no element in the set, that is called as a null set or empty set. So for example, see here, no elements means, see here, a equals to x such that x is an odd number which is divisible by 2. Odd numbers, first of all, odd numbers are divisible by 2 or not? No. So but here given divisible by 2, so any odd number will be there which is divisible by 2. No. So that's why by using this property there won't be any element. So that's why it does not contain any element. And this is a null set. A null set is represented as pi. So pi means you can write as pi as only simply empty brackets. Okay. So if you want, you can see here also the definition: empty set or null set. Empty set or null set. Okay, so next, a set which does not contain any element is called an empty set or a null set. Example: x says that x is a natural number between 5 and 6. Between 5 and 6 any natural number will be there? No. After 5 we will get 6 only, no? Between 5 and 6 no natural number will be there. So that's why it is example of empty set. M equals x says that x plus 3 equals 0 and x belongs to W. So see here, x plus 3 equals 0 means x is equals to plus 3 coming this side means minus 3. X equals to minus 3 and x is a whole number. How it is possible? Whole numbers will start from 0 onwards only, no? How? In the negative, okay, in the whole number there won't be negative numbers. So that's why there is no x which satisfies both the condition. That means x plus 3 equals 0 and x belongs to W. These two conditions satisfy చేసే విధంగా ఏ ఎక్స్ కూడా ఉండదు అన్నట్టు. అందుకోసం ఇది ఒకటి నల్ సెట్ అన్నట్టు. దిస్ ఈస్ ద ఎగ్జాంపుల్ ఆఫ్ నల్ సెట్. ఎంటీ సెట్ ఈస్ డినోటెడ్ బై గ్రీక్ లెటర్ పై ఆర్ ఎంటీ బ్రాకెట్. Number of elements in null set is 0. So any element will be there in the null set? No elements. No elements are denoted by 0, no. So that's why. So next see here, empty bracket, okay, in the pi, next bracket, in the bracket, again bracket, in the bracket 1 0 are non-empty sets. So it is not an empty set. It is a set which contains the element pi. It is a set which contains an element closed bracket. It is a set which contains an element O. So that's why in these three sets elements are there. Elements means not only numbers, anything, whatever we are writing in the sets, all those comes under elements only. So all these are non-empty sets. So yes, next coming to the next one more thing, one more definition we are going to discuss: finite set. Finite set means if a set contain an finite and infinite sets. If a set contain an infinite number of elements, then it is called as an infinite set. Okay, so if a set contains infinite number of elements, if a set contains an infinite number of elements, then it is called as an infinite set. And if a set contains a finite number of elements, then it is called as a finite set. Example: a equals to 3 6 9 12. Here only finite number of elements are there, means we can count and say how many elements are there: 1 2 3 4 5. So 5 elements are there, like that we can count and say. Okay, so that's why it is the finite set. Finite number of elements are there. Next coming to this, b equals to 3 6 9 12 and so on. It is an infinite set. We are unable to say how many elements are there: 1 2 3 4 and so on. How many elements are there? We cannot count how many elements are there. We cannot say how many elements are there, no. So that's why it is an example of infinite set. Infinite set, infinite number of elements will be there. Finite set means finite number of elements will be there. Finite set means we don't write dash dash dash. Infinite means dash dash dash. Okay, next coming to, so subset. So what is meant by subset? Subset means if all elements of a set are also present in another set B, then A is subset of B and represented symbolically as A is subset of B. For example, see here, A equals to 1, 3, 5 and B equals to 1, 2, 3, 4, 5. So here see here all elements of A, here all elements of A 1, 3, 5 are also present in another set B. So 1, 3, 5, 1, 3, 5, okay, all elements of A are present in set B, no? So that's why we can say this set A is subset of B. So then we say that set A is subset of B and symbolically we will use that A is subset of B. Okay, so that means A is the, so all the elements of A will present in B, means B will have more elements of more elements than A. Okay, so when some sets are taken and analyzed, okay, generally we will take A and B like this, we have taken and analyzed. The set from which these sets are taken is called universal set. Okay, here for example, here 1, 3, 5, 1, 2, 3, 4, 5 we have taken. So these two sets from where, from which sets we have taken, that is called as universal set. For example, see here, natural numbers 1, 2, 3 and so on, 1, 2, 3, 4 and so on. From the natural number set, if you have taken prime numbers, what you will say? Prime numbers means 2, 3, 5, 7, 11 and so on. So now this prime number set we have taken from this natural number set only, no? So that's why this set is called as universal set of this prime number set. Okay, if I give you one more definition, I will give you universal set. Universal set means a universal set is the collection of all objects in a particular context or question. So in the question, whatever the objects are there, okay, all objects collection is called as a universal set. If we study about the students of a school, okay, for example, it is the context, it is the situation. We are studying about the students of the school. Then the set of all students in that school is universal set. Okay, if we study about the school students, okay, all the students will comes under universal set. Okay, subset means 5th class students, 9th class students, 8th class students, like that. Universal set is denoted by the Greek letter mu or u. It is mu, M-Y-U, mu or u. So we use rectangles for representing universal sets in Venn diagram. So to represent universal set, we use rectangles. Okay. So subset already we discussed. If all the elements of set A is present in B, then A is said to be subset of B. Then we say that if we write A is subset of B, it means that set A is subset of B and B has more elements than A. If set A is not the subset of B, then we write A does not subset of B. Subset symbol we should write down like that. We should cut that. Okay. So next, one more thing. A universal set is generally represented by U or mu. Every set is a subset of the universal set. Okay, all the sets are subsets of universal set. From the universal set itself, we will take no. So that's why. When two sets, now equal sets. What are the equal sets? When two sets have same elements. If two sets have same elements, then the sets are called as equal sets. For example, if P equals to X such that X is a multiple of 12 and Q equals to X such that X is a multiple of both 3 and 4, then P equals to multiple of 12. 12 multiple, 12 table write down 12 1 12, 24, 36, 48. And also multiple of both 3 and 4. 3 and 4 multiples means 3 4 the LCM we have to take 12, means again 12 multiples only we will get. So here 12, 24, 36, 48, 12, 24, 36, 48. All the elements of P are same as all the elements of Q. That's why these two are equal sets. Hence P and Q are equal sets. Okay. So now types of sets are completed. Next, cardinal number of sets I will tell you. So now cardinal number of a finite set. Finite set means already we know, no? What is that? If there are finite number of elements are there, that set is called as a finite set. Okay, if there is no dash dash dash, that is the final set. So the number of elements in a finite set is called the cardinal number of the set. Cardinal number of the set means what? Number of elements in a finite set. Okay, in the set how many elements are there? Just we should count and write down. So that is the, that number is the cardinal number of the set. We denote the cardinal number of a set A by n of A. So n of A means number of elements